Counting by Binary. Music by a personal friend, Mike Holt, aka DJ Angle. We use a number system called decimal on the day-to-day basis. It's a 10-digit number system using 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Binary is a 2-digit number system using 0 and 1. To understand how to count in binary, we must fully understand how to count. I know that seems kind of simple, but it's necessary. We use this what we call the place value system, and each column in our numbers represents a certain value. You have the ones column, the tens column, the hundreds column, the thousands column, and so on. In binary, we have a similar thing. We have the ones column, the twos column, the fours column, the eights column, and so on, doubling in procession like normal. Count normally, we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so on. In reality, we do this. We start with 0 in the ones column, add 1, 2, 3, 4, 5, 6, 7, 8, 9. We're adding 1 to the ones column each time. Now, when we add that 10th 1 to the ones column, we don't actually do that. We actually add a 1 to the tens column and revert the numbers back to 0 in the ones column. Each column goes through the numbers we use, 0 through 9, then resets, adding a 1 in the next column. In binary, we use the same principle when counting. We have a chart here with our decimal numbers represented on the left hand side and our binary numbers across the top in the columns, the eights column, the fours column, the twos column, the ones column. And we use the 0 through 1. So it's only 2 numbers to roll through each time. Well, here we're going to start with 0. And we go to 1, and we have a 1 in the ones column. Now to get to the number 2, just like in a tens column, you would go add the 1 to the twos column, and that would be it. It reverts back to 0. Now to make a 3, you would just have the 1 in the twos column and then add the 1 in the ones column. And then so forth for the 4. You would add 1 to the 4 column and revert the others back to zeros. Just like it goes through the loop, 0 through 9. We're going 0 through 1. And then you go to 5, you have a 1 representing on in the 4 and the 5, the fours column, and then a 1 in the ones column to represent 5. Now to represent 6, we have a 1 in the fours column and a 1 in the twos column. And to add 1 more to that, we just add 1 in the ones column. And then the eights column to make 8. And then the ones column, and the eights column to make 9. Then we use to 10, we go with the eights column, and then the twos column. 8 and 2 equals 10, 8 and 1 equals 9, 8 is 8, 4, 2, and 1 equals 7, 4 and 2 equals 6, 4 and 1 equal 5, 4 is there, 2 and 1 equal 3, 1 equal, right here, 2 equals 2, and 1 equals 1. Again, 0 through 1, then add 1 to the next column. If you were to count to 100 in binary, adding 1 through every column would take forever. So here's a little shortcut. First, I drew my place value system for binary up, and I have a ones column, a twos column, a 4's column, 8's column, 16, 32, 64, and 128. Now we're only counting to 100, so I don't need to go any further than this. Now, this is another way to convert decimal to binary, but here's what I do to count as well. I say I need 100. So the first number that's big enough that's less than 100 is 64. Now I take 100 minus 64 and I'm left with 36. Then I say, what is the largest number in my place value system that is less than 36? That's the biggest one. It's going to be 32. So I take a 1 here and a 1 there. And then I have 4 left. And I know I have a 4's column, so I'm going to go ahead and put a number here. And then what you want to do with the rest of those numbers is you're going to fill in with zeros. Seeing how we have 2 numbers in our number system in binary, not just 1. So we're going to fill in these blank numbers. Now, in binary, you're usually grouped in numbers between in groups of 4. And we call these octets. But that's further on and more in depth. It's out of scope for this video. Now, what we do here to convert back to decimal is we add up all of our ones that we have. So we have a 4, a 32, and a 64. And obviously all those add up to 100. Binary addition. We have 1 plus 1 equals 1, 0. And that's basically all you need to know for binary addition. 1 plus 1 equals 1, 0. Right? So plus 1 would equal 1, 1. Now, 1, 1 plus 1, 0 plus 1 would be 100. And here we go, and how we actually do it here. 1 plus 0 is 1, plus 1 is 1, 0, plus 1 is 1, 1. So we put the 1 down, and we carry it over. 1 plus 1 is 1, 0, plus 1 is 1, 1. Put the 1 down. We carry the 1. 1 plus 1 equals 1, 0, plus 1 equals 1, 1. There we go. And as you can see, this right here is the number 1 represented in binary, 2, 3, 4, and 5. Right here, we have 1, 2, 3, 4, and 5. And that adds up to 15. Now you have 4 binary digits in each column. We have the 1s, the 2s, the 4s, and the 8s. 8, 4, 2, 1. So we put a 1, a 1, a 1, and a 1 in each one. 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. And there it goes. Ta-da! Thank you for watching.